Good morning, everyone. My name is Yuan. I'm in charge of our network architecture transformation in Huawei. So it is my pleasure to be here to share some of our visions about the future. So today my topic is 5G-oriented autonomous driving network. We believe it will be the future step after this cloudification. So I will tell you why. Okay. So first, I would like to take this chance to share some other global industry visions for 2025. So we predicted 10 major industry trends for the future. So among them, you can see that we predict almost all the big enterprises, they are using AI technologies in their service and their operation. And also, we are going to live with and work with more and more robots which are around us. So you can see the intelligence is more pervasive. And also for 5G, we estimate that by 2025, almost 60% of the world's population will be covered by the 5G areas. And also you may notice that there's acceleration deployment of the 5G in Chinese market. So we can see the future ubiquitous connectivity, pervasive intelligence, and also digital form consists of some of the major trends for our network. And we believe the 5G and AI can bring lots of new business opportunities for us. And at the same time, we also know that there's still some other structural challenges the telecom industry are facing with. So you can see the graph here that if you look at the graph, the CapEx is always the same year by year, but the OpEx part, which is 3 times then the CapEx, is still keep increasing. I think the major reasons behind this is the technology and the network becomes more and more complex because you need to support the 2G, 3G, 4G, even coming 5G at the same time. That will make these things much more complex. If you look at all these OpEx issues, there are 3 major parts: the rental fee and operation maintenance. And also you need to pay the electric bill to the power companies every month. Okay, so for the rental fee, you can see the current situation is that you have many ports. Different ports probably support different kinds of technology, and also you need still need many indoor facilities to accommodate some of the indoor equipment. So that really costs a lot of the rental fee for the carriers. So we need to find out a better way to support this different kind of technologies. And the second one is that energy consumption. So here is the current energy consumption curve. So you may notice that actually this curve is almost flat. It means that no matter you have the traffic in your network or not, so you need to pay the electric bill. So there's a lot of space we think we can improve this for our customers. The third one is operation and maintenance. So as I mentioned, that the technology and network architecture becomes more and more complex. Especially you think you introduce the 5G. If you still use the traditional way, it means that you need more people to help you to maintain this network. So, and ironically, based on Huawei's statistics, 70% of the network faults coming from the people, from the human. So I think we need to also need to find a new way to help the carriers to maintain and operate this network. And for Huawei, we believe that those kinds of structural challenges cannot be only solved by product innovation. It should be solved by some architecture innovation. So if you are familiar with Huawei's strategy about network architecture, you may know that about 10 years ago, we had our OIP strategy to transform all the TDM to the OIP architecture. About 5 years ago, we had our all cloud strategy, move everything to cloud, make the resources more efficient for our customer. And what is the next? So we believe the next will be like more intelligent network to introduce some AI, intelligent technology into our network. So we call it autonomous driving network. We hope that we can work together with the industry for this target. Obviously, it's a long time strategy. And also think big, we need to act some small. So later on, I will introduce some of the user cases which already was developed based on this architecture. You can see some of the benefit we can get from this ADN architecture. Okay, so here is actually the reference framework for Huawei's autonomous driving network. Actually, it consists of the two parts. The first, the simplified network. We believe that each layer of the network should be simplified. We need to have some simplified RAN. We need to have some simplified transport. We need to have some simplified core network, and including edge computing. Because we believe that is the fundamental to enable this autonomous driving network. Then the second part is intelligent operation. So for Huawei, we have the new brand we call the Master. So there's several components in this architecture. The first, we call it the single domain autonomous component. So we have the Master NCE for FBB fixed broadband. We have the Master MAE for the mobile broadband. At the upper layer, you can see we also have some cross-domain autonomous components who is taking charge of all the synergy among all the different domains. Of course, they take care of some multi-vendor issues. On the top, you may notice that it's something new for the telecom industry. We call it AI network engine, and it's kind of an AI training platform. So target of this platform is to try to help to lower the barriers for those developers to introduce the AI technology into the telecom industry. So that's the whole architecture of our Huawei's ADN reference framework. Okay. So then I would like to introduce the simplified network first. So you can see that that's the current situation right now. We have many poles, we have many indoor facilities on the rooftop. That really costs the customer a lot. It carries a lot for the rental fee. Okay, so we believe in the future that everything will be in the same pole. So all banding in one, which can support all the spectrums, all the different technologies together. And also we believe that in the future, we need to put everything on the pole. So not only about the microwave and BBU, AAU, batteries, everything on the pole. So in that case, we can help the carriers to save the tremendous rental cost for those rent. So we believe that kind of architecture can bring a lot of benefits to our carriers and the customers. And the second is about the transport network. Okay, based on some historical reasons, you may notice that for IP network, there's many protocols. So L2, Layer 2 VPN, L3 VPN, and LDP, MPLS, many protocols, more than 10 protocols in our IP network. So if you want to onboarding some new service based on this so many complex IP network, so you will find that it's very difficult. Because, for example, I can give you an example. We have several cases. One case that we want to onboarding some of new service on this IP network. So we need to configure the data in different various 8 nodes. But the 8 nodes, it's actually managed by the different organizations within the carriers. So actually, it takes a very long time to configure those data. And also, it's very difficult to make those end-to-end automation of the configuration. So we believe in the future for this IP network, SRv6 and VPN will be the future for this IP network. So that will largely reduce the complexity of this IP network. And of course, you can see that it'd be relatively easier to accomplish some automation for this configuration and one hop to the cloud. And also, it will support IPv6. And for core network part, so you may notice that on the left side is a very complex structure. You have many components in the core network side, and all of them connect to each other. So sometimes it's very complex for you to maintain this network. So for Huawei, we believe that in the future should have some one-core solutions. So the one-core means that the convergent architecture, the unified data, and a unified control plane, and a unified gateway. And most importantly, all of these components should be managed centrally, including those those edge computing node. So we can, based on this architecture, we can fulfill some of the features like plug and play. Okay, then I want to move to the intelligent operation part. So first, I would like to introduce some of our single domain autonomous component. So you may notice that currently you have many functions in your network in operation. You have the management from the EMS, and you have some SDN controller to help you, which can help you to control the network. And also you have some analyzers, probably can help you to make some, to see some insight about your network, to what's happening in your network. But currently those kind of functions are working independently. So for Huawei, we believe that those kind of functions should work right close, should be integrated as one domain, one component. So we believe that except those management engine, we need a control engine, and we need an inference engine, and also we need an analysis engine. So put them together to achieve some of the goal of the closed loop. So we believe probably it's time to think about reimagine the role of EMS, to move it from the purely management to the convergent architecture, which includes the management, control, and analysis, even some intelligent. Okay, talking something about theory. Then I would like to give you some of the user cases, which can show some of the benefit we can get from this kinds of ADN architecture. So I want to present one case for fixed broadband, one case for mobile broadband. So this is one case for energy saving for the base station. So actually, for Huawei, this kind of features is not new, because we already provide this kind of feature to our customer probably 2 years ago, 1 year ago. But the problem is this kind of feature is not widely used. Why? Because the current for those kind of old solutions, the threshold to decide when you should shut down some of the cell is very simple and static. So it cannot guarantee because you know that for each of the cell, the traffic model is different. So by using those simple ways, static way, you cannot guarantee the network KPI. So our customer cannot dare not to use those kinds of features, even it's very useful for them. So how? So then I will explain how the artificial intelligence can help us to improve this use case. So we collect all the historical data for each of the cell. They put that we use those kinds of data to train our models for those specific cell. So we can get very relatively precise prediction about those traffic models for that specific cell. So based on this, we can make those shutdown policies more precise for each of the cell. Okay, so and the second, we put that into execution for each of the cells. Then we can also get some feedback from those cells and try to optimize it later on by using those reinforcement learning mechanism. So really, we've been cooperating with some of the leading operators for these use cases. We got some of their achievement can help carriers to realize some probably more than 10% energy saving in these areas. And here I have another case for fixed broadband. So for optical network health prediction. So you may know that the fiber network is passive network. So normally it's very hard for us to predict the problems and locate the problems where it happens. So that's the current situation. So based on our statistics, the slow change faults accounts for 20% to 50% of the total problems. So normally it's very difficult for us to detect and to locate the problems. So actually, most of the time, we only get to know these problems by customer complaint. Otherwise, we don't know this kind of problems. So how the artificial intelligence technology can help us to improve these kinds of operations. So for Huawei, we have, based on our experiences in these areas, we have many data already in these areas. So we use these data to train these data by some machine learning algorithm to create some models which can help us to identify the different status of the network, such as the healthy, sub-healthy, and the false status. Then after train this program, train these models, we put that into the execution. Then based on some real data we get from OLT, ONT equipment, like those, those emit powers and receive powers, those kind of parameters, we can make some evaluation about this current status of the network and even make some prediction. So this really helps us to understand what happened in this optical network in advance. So based on our experiences, by doing some trial with some operators, so we can really help to help the carriers to predict almost 90% of this kind of problems in advance. So that really benefit to our customer. So then I would like to move to the cross-domain intelligence. So as I mentioned, the cross-domain autonomous component is taking charge of the multi-domain collaboration. So it's a kind of end-to-end, those kind of end-to-end issue to be taken care of by this cross-domain autonomous component. Of course, this component is also taking charge of the multi-vendor issues. Okay, so based on this, we can already support the fixed broadband, mobile broadband, and also NFV as DN scenarios. Then I want to give you some of the examples how this cross-domain work to bring some benefit to our customer. Okay, so for carriers, every day you have a huge amounts of alarms, right? But not all the alarms is important for you, and some of alarm probably may correlated. So we are trying to find a way to help you to reduce those tickets which caused by those alarms, because each of the ticket means the cost for you. You need to send some people to handle those problems. I can give you one examples here. If there's a transport device power failures, which actually normally will cause 11 work orders. So one for power, one for BTS, and for access and the transport part. So actually all those work orders coming from the same fault. So it's not so efficient and by using a traditional way. So how we can use those artificial intelligence can help us to improve the efficiency here. So there are 3 steps. The first step, we are using a very traditional way to help us to comprise those alarms, probably 20% of the original alarms by using this way. The second step, we are using AI-based multidimensional fault identification mechanism to help us to create co-relationship among those alarms, to try to create some of the event. Okay, so we call it event-driven ticket. Then the third step is that based on this event, we are going to use the knowledge map and knowledge graph technology to help us to demarcate where the problems coming from. Okay, so by using this kind of a new innovation approach, we can help carriers to largely improve the efficiency of your daily operation. Okay, then I'd like to introduce some of the Huawei's network AI engine. We call it Master NAIE. Okay, the target of this kinds of AI training platform is trying to lower the barriers for the developers to introduce AI technology into the telecom industry. So this network AI engine consists of the 4 parts: the data lake service and training service, AI marketplace, and also the inference framework. So first, you need to, in order to train your models, you need to input some of the data into this training platform. But sometimes you don't have so many data, but don't worry about that. Because for Huawei, based on our experience, we already embedded a huge amounts of the data, which cover from the wireless to the transport to the core network and the optical network into this training platform to help you to train your own model. Then Then, so after you have those data, you want to train your own model. Sometimes for some scenarios, you don't need to create your own model because there's some of the embedded models which was already based on Huawei's practice already in this platform. You only need to select some scenarios and fill some templates to help you to create those models. So that's the training and service. Then after you train your model, you probably want to release it into the AI marketplace. So the AI marketplace are going to send this model to the inference framework, which you can execute your AI models and evaluate the models, probably optimize the models later. Okay, so this AI inference framework could be deployed on cloud, and could be deployed under all the components I mentioned. We call it iMaster NCE, MAE, and even the cross-domain component outing. So that's how that works for this training platform. Okay. Then I'm going to introduce some of the cases, okay, for you to make you understand how that can help us to improve, to build up those AI models. So here, the DCPU optimization AI models. So actually, it's a real Huawei case, because before we have this training platform, we already did some of the AI project. It was last year. Okay, we put 8 persons. It took us 6 months to create this kinds of AI models for these scenarios, because lots of the efforts been put into the data governance, all those kinds of the feature extraction. But after we have this training platform, we only need 1 expert with 2 ways. We can do it now, because all the tedious work's been taken by these platforms, and also you can choose some of the existing AI models provided by the training platform. You only need to fill some of the template and choose some scenarios. That really helps to improve the efficiency of those, to create those AI models for telecom industry. Then I have another case. We already cooperated with some leading operators for this training platform. So we deployed this training platform to their public cloud, and we do some joint innovation to accelerate the adoption of those AI technologies in the telecom industry. Okay. Here's my summary. As I mentioned, there's the Huawei's autonomous driving network. It consists of 2 parts. The first is simplified network, simplified RAN, simplified transport, simplified core and the edge. Of course, if it takes a long time to reach this architecture. Then the second part is that intelligent operation part. So we have some single domain autonomous component. iMaster NCE for FBB, fixed broadband. iMaster MAE for mobile broadband. And also we have the cross-domain autonomous component. We call it iMaster outing. And then we have our network AI training platform. We call it iMaster NAIE. So we hope that we could work together very closely with the industry for the target of this autonomous driving network. Okay, so that's my presentation. Thank you very much for your time.